okay, first of all, do you have a highlighter? All right. So it says figure 2 shows the major tectonic plates covering Earth's surface. Earth's lithosphere is broken into about a dozen massive plates and many smaller ones that are slowly moving across the face of the globe. All plates except the Pacific plate include parts of continents and ocean basins. I would highlight that just simply because the Pacific plate is an exception, because all of the other major plates have at least some continental crust, and the Pacific plate really doesn't. Okay. In some places, plates are spreading apart, forming divergent boundaries. We've learned that. Plates are colliding in other places, forming convergent boundaries. And some plates sporadically slide past one another. These are transform plate boundaries. What does sporadically mean? Okay. Do what? Yeah, it's like it just kind of happens when it happens. It happens sporadically. It doesn't happen regularly. It's just kind of all of a sudden unexpected. Does that kind of make sense as far as sporadic? Yeah, I mean, it happens sporadically. We know it happens from time to time, but it's hard to pinpoint when it's going to happen. It's not on the schedule. Yes, exactly. So plate boundaries are where crustal materials are either created or destroyed. Now, think about this. What plate boundaries are we creating crust? Come on. Think. Where is crust created? When the magma comes out, which is along where we get seafloor spreading, a mid-ocean ridge, and that is at a what kind of boundary? Where plates are spreading apart. That's at a divergent boundary. Very good. All right. Where are we getting crustal material destroyed?
That's when the whole thing, the subduction zone.
Okay, so yes, at a subduction zone where you've got plates doing what? Colliding, which is called? Converging. And you get the denser plate being pushed back into the mantle and being destroyed and recycled, basically. Okay, good. Geological processes associated with plate boundary movements include earthquakes, volcanism, and mountain building. All right, so here we go. It says, according to figure 2, the U.S. is located almost entirely on, okay, so it requires you to know where the United States is. Where's the United States?
North American plate.
Okay, so here's the United States. Here's Alaska, which is part of the United States. So almost all of the United States is located on the North American plate. So your choices were Aleutian, Cocos, Cascade, North American. So pick the appropriate one and circle it. No, that's what I'm saying is they gave you like some bogus plate. But anyway, just to see if you were... Well, the Aleutian refers to the Aleutian Islands, but there's not an Aleutian plate. So they just gave you, they like made up one. Yeah, and like there's not a Cascade plate as far as I know either, unless it's a really small one. Okay. I know I did. Yeah, I didn't include all of them, but all of the ones that were included were labeled. Okay. So we're going to circle North American. Or highlighted it. Okay, here we go. Ocean trenches are deep, elongated depressions on the ocean floor formed along convergent plate boundaries where the edge of one crustal plate has been forced under the edge of another crustal plate. The process known as subduction. That's worth highlighting because you do need to understand that it's at a subduction zone that you're going to have trenches forming. Mid-ocean ridges are underwater volcanic mountain ranges formed at diverging tectonic plate boundaries, typically extending thousands of kilometers with central valleys known as rifts running along their spines. Okay, so let's think. And I'm going to put this out in the margin because I want you to write this down. All right. In the middle of the Atlantic Ocean, we have a divergent boundary, correct? Plates are moving apart. What is in the middle of the Atlantic Ocean? A mid-ocean ridge. So where plates diverge, you get ridges. At convergent boundaries, at convergent boundaries where one plate is forced underneath another one, what do you get? Subduction. And what feature? What crust feature?
Volcanic.
You can get volcanic mountains, but oh Lord. Ocean trenches are deep. Okay, so at convergent boundaries we get trenches. Okay, so just keep that in mind because that'll help keep us straight for the rest of this. Okay. All right. I'm going to make that partially disappear so we can go back to this. All righty. It says, according to figure 2, here's figure 2. According to figure 2, a what curves down the middle of the Atlantic Ocean basin?
Ridge.
A ridge. Yeah, it's the mid-Atlantic ridge. So make your pick, highlight or circle. Okay.
I know it's a ridge.
We're doing the second one right here. Okay. This prominent feature roughly parallels the boundaries of the continents and their adjoining shallow continental shelves on either side of the Atlantic Ocean basin. That is, this feature is roughly midway between the continents of Europe and Africa to the east and North and South America to the west. Okie dokie. Next paragraph. Geologic evidence indicates that the land masses on either side of the Atlantic Ocean were once joined together as one supercontinent known as Pangaea. The Atlantic Ocean basin was formed when Pangaea split apart. The volcanically active mid-Atlantic ridge marks a divergent boundary. There you go. Well, but that's, remember, that's part of the reason why we stopped and did this, because we wanted to remind ourselves that at divergent boundaries we get ridges, and at convergent boundaries we get trenches. Capiche? Okay, so here we go. So the volcanically active mid-Atlantic ridge marks a what? It's a ridge, so it's a divergent boundary. Okay. All right, in figure 1, all right, hang on, I got to get figure 1. Here we go. There's figure 1.
Is that like a thermal?
Yes, no.
It's not thermal.
It's elevation.
Yes, it's an elevation.
So like.
It's a relief map, so it shows different elevations. So, for instance, the orange and the red are high elevation. The blues and the greens are low elevation. And it's actually kind of hard to see, but right along the west coast of South America, it's so dark blue it looks almost black. Right along here's the Aleutian Trench right here. So all of those really dark marks along the continental margin, those are all trenches. Okay, so let's read the rest of this. In figure 1, again note the thin dark lines representing trenches that run along the western margin of South America, Central and North America, the Aleutian Islands and beyond. Trenches form where the rigid ocean floor is forced under another plate, forming a subduction zone. As adjacent tectonic plates converge. Yes, we've said it over and over. Remember, convergent goes with trenches. Okay? So, as adjacent tectonic plates, and we're going to circle converge. The trenches seen in this view form part of a ring extending around much of the Pacific Ocean basin, which is also site of active volcanic activity termed the Ring of Fire. Whereas the Mid-Atlantic Ridge, I had a Johnny Cash moment over there. Whereas the Mid-Atlantic Ridge is a site of seafloor spreading and the formation of new oceanic crust from lava welling up from the Earth's interior, a deep-sea trench forms where oceanic crust descends in a subduction zone. That is worth highlighting, so highlight that. Okay, we got to find it first. There we go.
Did that show up on the
Yeah, it probably did. Okay, here we go. It says, whereas the Middle Atlantic Ridge is the site of seafloor spreading and the formation of new oceanic crust, a deep sea trench forms where oceanic crust descends in a subduction zone. Where an oceanic plate subducts beneath another plate, a unique geological environment forms. In the wedge-shaped region between the plates, melting can occur, resulting in violent volcanic eruptions. Or building of stress can take place where adjacent portions of the rigid plates temporarily lock together. When they suddenly move relative to each other, energy is released that generates powerful earthquakes. Any questions? Okie dokie.